Now, I will go to the next question. Two identical conducting spheres A and B are separated by a distance greater than their diameters. The spheres carry equal charges and the electrostatic force between them is F. A third identical uncharged sphere C is first brought in contact with A and then with B and finally removed. As a result, the electrostatic force between A and B becomes, let A and B be two identical charges separated by a certain distance. I call the first one as A and I will call the second one as B. You all agree that if the separation between A and B is D, then the electrostatic force between them is K multiplied by Q square divided by D square. I assume that the charge on each sphere is Q. Now, suppose there is an identical third charge and I call it to be equal to C. If I bring C, which is uncharged, in contact with A, you know that charges exchange between the two spheres till their potentials become equal. Since the charges are only on A but not on C, and since the dimensions of the two spheres are same, the charge on A and C will be same only when they are equally divided. Hence, the charge on A will be Q by 2 and the charge on C will also be equal to Q by 2. Now suppose you take C and bring it in contact with B. The charge on B was Q, the charge on C is Q by 2. This total charge will get equally divided between the two. On account of that reason, the charge on each will be equal to 2Q plus Q is 3Q divided by 4. Note one thing, that if now C is removed, charge on A is Q by 2, charge on B is 3Q by 4. Therefore, new force between A and B will become F dash is equal to K multiplied by product of the two charges. Q by 2 into 3Q by 2 is 3 divided by 8 Q square divided by separation will be the same, therefore divided by D square. But you agree that K into Q square by D square is equal to F. Therefore, F dash is equal to 3F divided by 8. Therefore, second option is the correct answer. Now, I will take one question based on electrostatic energy. Let me now read the question. Three charges, capital Q, plus small q and plus small q, are placed at the vertices of a right-angled isosceles triangle as shown. The net electrostatic energy of the configuration is 0 if capital Q is equal to. That's it. For your reference, let me draw the figure again. This charge is capital Q, this is small q, this is also equal to small q. The side is A, naturally this will be A, and the hypotenuse will be equal to A root 2, will be equal to A root 2. Then, you know that electrostatic energy consisting of a system of three charges Q1, Q2, Q3 is k, I once again tell you, small k is 1 upon 4 pi epsilon 0. Q1 Q2 divided by R12 plus Q2 Q3 divided by R23 plus Q3 Q1 divided by R31. Therefore, electrostatic energy of the system E is equal to K into bracket Q1 Q2 Q into Q divided by the distance A plus, if I consider this, Q2 Q3 Q into Q is Q square divided by the distance is again A plus this and this, it is again Q into Q divided by the distance is, it is going to be equal to A root 2. Now, in this case, you can agree that if this electrostatic energy should be 0, quantity inside the bracket should be 0. I will remove the common term Q by A, Q by A, Q by A. Therefore, in order that bracketed quantity should be 0, Q plus small q plus capital Q divided by root 2 should be 0. If I now take a capital Q common, 1 plus 1 divided by root 2 is equal to, if I take Q on that side, it is minus Q. Therefore, if I make a Q the subject of the formula, it is minus Q multiplied by root 2 becomes LCM, it will go to the numerator, divided by 1 means it is root 2 plus 1. Multiplying both the numerator and the denominator by root 2, one can see that the condition can be written as minus Q divided by 2 plus 2 plus root 2. Therefore, you can see that option number 2 is the correct answer.